Bismillah ar-Rahman ar-Rahim. Welcome to lecture 3 on probability. اليوم راح نتكلم عن joint and conditional probability. Joint and اوكي. نتكلم عن الجوينت probability the probability of PA intersection B is called the joint probability for two events A and B. Okay. And if we look at the Venn diagram, and this is our S, and we have A. So this is A, this is B. Then probability of A intersection B is equal to the probability of A plus probability of B minus the probability of A union B. Okay. So this is the definition of the joint. Sometimes in some books you will find those this notation to be written probability of A dot B. So this is an AND operation. Instead of intersection symbol, they use the dot, which means that this is probability of A and B. Okay, so we can, sometimes you can see this, or you will see it in some books. Okay, it's easier to show that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, or probability and B. This one is much easier than seeing this one here, because the union means that you will have the probability of A plus the probability of B. So this here, when you do the union, you will just put the common factors or the common events between A and B once. So it will be recorded here in probability of A and probability of B. So it is twice, so you have to subtract them once. So probability of A contains this part. Probability of B also contains this part. So you have to subtract it. So probability of A union B is the probability of A plus the probability of B minus the intersection between them. Okay, because you have to just include it once, not twice. And it is included twice in the because of A and B. Okay. Now, if A and B are mutually exclusive or disjoint, this means that A intersection B equals phi, which means that probability of phi equals 0 and probability of A union B is equal only probability of A plus probability of B. So there is no subtraction. Here in this case, you will have A and B, and this is our S. So probability of A union B equals probability of A plus probability of B. Okay. Moving to the next item, which is the conditional probability. Let's define it first. Conditional probability given some event B with non-zero probability so probability of B is greater than 0, then the conditional probability of an event A given B is probability of A given B. So we have backslash A given B, and we say that this is the probability of A given B. This is equals to the joint probability of A and B divided by the probability, or normalized by the probability of B. Okay. So this is the probability. If A and B are mutually exclusive, this means that A intersection B, or A and B, equals to phi. This means that the conditional probability A given B is equal to 0. Okay? So this is the conditional probability. Okay. Based on the conditional probability, let's define something called the total probability. Total probability. Okay, let's do this on the Venn diagram first and see what will happen. Okay, let's assume that this is your S, this is your sample space. It is divided into so many disjoint events. So this one is B1, B2, B3, and this one is B sub n, and this one is B sub capital N. And we will define an event A over those mutually exclusive events, and let's assume that this is my A. Okay, so you can see that this part here, so this is my A, and you can see that this part here is A intersection B sub n. So this part of the event of A, or this part of A, is A and, or the joint probability between A and Bn. So what we have here, we have, or we are given n mutually exclusive events B sub n for n equals 1 to up to capital N, where, or sorry, whose union is S, and they are mutually exclusive, which can be put in mathematics as B sub M intersection with B sub n equals to phi, given that M not equals to n equals 1 to up to capital N. So those events are mutually exclusive. And the other thing is that their union from n equals 1 up to capital N, B sub n is equal to S. Okay? If we have this, then what will be the probability of A based on those mutually exclusive set? Then the probability of A is equal to the summation from n equals 1 up to capital N, probability of A given B sub n times the probability of B sub n. This is known as the total probability of the event A. Actually, since those B sub n's are disjoint, then those also. So notice that this one, let's say that this one is B3, this one is B4, B5, B6, and B7. In this case, you have B4, A intersection with B4, A intersection with B5, A intersection with B6, and all those events are also disjoint events because the BNs are disjoint. So the probability of those events together is the total probability, which is the probability of A. Now, if you go to the conditional probability and make sure that do the relationship between the joint probability and the conditional, you can get this answer here, okay? You can prove this. Please try. Or they try to prove the total prove this. Okay? Okay. So, another theorem that is related to the conditional probability is the Bayes theorem. Bayes' theorem stated that the probability of Bn given A is equal to the probability of Bn intersection A divided by probability of A. And if we take the opposite, probability of A given Bn, then this is equals to probability of A intersection Bn over probability of Bn. Now, look at the numerator here. This numerator and this numerator are the same. The intersection is a commutative operation. So Bn union A is equal to Bn intersection A is equal to the A intersection Bn. So their probability are equal. And we can replace one by the form of the other one. So I'm gonna take this one here and put it. So I'm gonna say that what is the probability of Bn given A is equal to the probability of, so I'm gonna multiply. I need this one, Bn given A. So I'm gonna multiply this one here, find this one and replace it here. So this is probability of A given Bn times probability of Bn divided by probability of A. Now, if we use the total probability for the probability of A, we can say that probability of Bn given A is equal to probability of A given Bn times probability of Bn divided by probability of A given B1 times probability of B1 plus probability of A given B2 times the probability of B2 until probability of A given B sub n times probability of B sub n. So this is what we know, or what is known to be the Bayes theorem. So this is the Bayes. So this is the Bayes theorem. I'm going to solve an example using this concept. Let's go to a very simple elementary communication channel. We have a transmitter, we have a receiver, and see what will happen. So we take an example. In this example, we have an elementary binary communication system. So we have here at the transmitter, and we have here the receiver, and this is here the channel. So we have the channel, transmitter, and the receiver. So we have here B1 as a binary and B2 as another binary. And supposedly, if we don't have any noise in the channel, all B1 will be transmitted to A1 at the receiver, all B2 will be transmitted to A2 at the receiver. Okay? Now, the probability of let's put it down just to make things neater. Probability of B1 is equal to 0.6 and probability of B2 is equal to 0.4. Those are known a priori, which means that you transmit the signal and you know how percentage. You have 60% binary bit 1 and 40% you send binary bit 2. Now, in the channel, there are noise added to the signal. So not all the B1s will be transmitted to A1. Some of them will be going to be added to, noise added to the binary bit, so it will be transmitted to A2 by mistake. So this is not something not good, it's something bad actually. And at the same time, you have also some of the binary B2 will also transmitted or noise added to B2 through the channel, positively or negatively, and it will be mistakenly at the receiver decided to be A1. Okay, now the probability of A1 that you receive A1 given that B1 was sent is equal to 0.9. So we have 90% correct reception here. And at the same time here also, the probability of A2 given that B2 was sent is also equals to 0.9. Okay? So we have probability of A2 given that B1 was sent should be the rest of this one, so it's 0.1. And the probability that you have A1 received given that B2 was sent, it's the rest coming from this one, so it's equals to 0.1. With those values, 0.9 and 0.9, 0.1 and 0.1, we call that the channel is symmetric. So you have a symmetric channel. Symmetric channel. Okay, what do we need here? We need to find what is the probability of receiving A1. Find probability of A1, probability of A2. What is the probability that B1 is received given that if B1 was sent given that A1 is received? So probability of B1 given that A1 was sent. Sorry. What is the probability that B1 was sent given that A1 was received? I'm sorry about this. Okay. Probability of B1 given that, B2 given that A2, probability of B1 given that A2, and probability of B2 given that A1. Okay? 1, 2, 3, and 4. Okay. So those are the probability that we need to decide. Okay. Let's go and find what will happen. By using the total probability, probability of A1 is equal to the probability of A1 given that B1 was sent times the probability of B1 plus the probability of A1 given that B2 was sent times the probability of B2. This is from total probability, and the answer will be 0.9 times probability of 0.1, 0.6 plus 0.1 times the probability of 0.2. Probability of B2 is 0.4, so we end up with 0.58. Probability of A2 is also the same. It's probability of A2 given that B1 was sent times probability of B1 plus probability of A2 was received given that B2 was sent times probability of B2. And this is equals to 0.1 times 0.6 plus 0.9 times 0.4, and this is equals to 0.36 plus 0.06, it's equal to 0.42. Notice that the addition of those two is equal to 1. So this one plus this one is equal to . So the addition of those two is equal to 1, which is what we actually looking for. You have only two outputs, and their probability should be unity. So the total sample space at the receiver should have also a certain event. Okay. What is the probability of B1 given the A1? Probability of B1 given A1, which means that what is the probability that B1 sent given that A1 have been received? So this is equals to probability of A1 given B1 times probability of B1 divided by the total probability of A1, which is already found here. So this is equals to 0.9 times 0.6 divided by 0.58, and this is approximately equal 0.931. Okay? I'm gonna leave the other three items. So we find the first one here. This one, and this one, I will leave them for you as a practice. So do the other three as practice. Okay? Okay, with this we end up with this session, this lecture. Thank you very much, and we'll see you in next one. Thank you.